Okay, so in this video, I'd like to go ahead and take a look at linear equations with two variables, okay? So linear equations, so let's go ahead and write that down. Linear equations with two variables. And what do I mean by that, right? Now, oftentimes, you may see questions that look like this, okay? So let's just say that I have two equations over here. 4x plus 3y is equal to 13, let's say, and then x plus 2y is equal to 2, and now they're asking you to solve for x and y. These are linear equations with two variables, right? I have x as a variable, and I also have y as a variable. Now, how do I go ahead and solve this type of problem, okay? And the way you solve these types of problems are, you have two ways of solving this, okay? One way is substitution, and we'll talk about that in a second. And the other way is going to be elimination, okay? And we'll talk about how to do this problem by both ways. So let's go ahead and take a look at the first way that you can go ahead and solve this problem is by substitution. Well, let's go ahead and see, all right? I have my first equation here and my second equation here. 4x plus 3y is equal to 13, and my second one is x plus 2y is equal to 2. And what I want to do, and how I usually go ahead and approach these kinds of problems, is I usually just go ahead and first focus on my second equation over here, and I set this equal to this entire equation to either x or y. What do I mean by that? So let's just say I want to solve for x, okay? So I want to solve for x, so I have to manipulate this over here, x plus 2y is equal to 2. I have to manipulate it so it's just x is equal to something. Please ignore this weird line over here, right? So x is equal to what? Well, if I want to get rid of this 2y, I have to subtract 2y from both sides, so it's 2 minus 2y. So I'm left with x is equal to 2 minus 2y. Okay, this is very important, okay? This is what I'm left with. X is equal to 2 minus 2y. Now, please bear in mind, and please keep in mind that both of these equations over here, this equation over here and this equation over here, the x value and the y values are exactly the same, meaning that if x is equal to 1 for the first equation, x is also equal to 1 in the second equation. So by using substitution, what I can do is I can take this x is equal to 2 minus 2y and plug it directly into the first equation's x over here. Why am I doing that? Well, I want to go ahead and get rid of at least one variable. I only want to work with one variable. Right now I have two variables, x and y. It's very ugly, right? I can't really work with two variables. If I have one variable, I can very easily solve it. So if I plug it in, well, what do I have? I have 4 times x. Well, x is equal to just 2 minus 2y, so it's 2 minus 2y plus 3y is equal to 13, right? And now I can go ahead and use my distributive property. So 4 times 2 is 8, minus 4 times 2y is going to be 8y plus 3y is equal to 13. And now notice that these are like terms, negative 8y and plus 3y. Well, negative 8y and plus 3y is minus 5y. So I have 8 minus 5y is equal to 13. And now, what would I like to, well, I want to ultimately solve for y. Well, what's y? What I can do is I can subtract 8 from both sides over here. So I have left negative 5y is equal to 5, right? 13 minus 8 is 5. So now I'm left with negative 5y is equal to 5. And now I can simply do what? I can go ahead and divide both sides by negative 5, so I can get rid of this side over here, and y is equal to 5 divided by negative 5, which is simply negative 1. So you see, we've now solved for y, which is negative 1. Please don't forget, and don't think that you've just solved this entire question. No, you still have to solve for x, right? So if y is negative 1, now I have to take this negative 1 and plug it into the second equation so I can solve for x, okay? So now what do? Let me go ahead and write down my original second equation. X plus 2y is equal to 2, but I know that y is negative 1, so it's x plus 2 parentheses negative 1, right, because that's y, is equal to 2. x plus, well, 2 times negative 2 is simply negative 2, so it's just going to be x minus 2 is equal to 2. And now I can solve just for x, and I'll add by both sides by 2. X is equal to 4. So what am I left with? After all this, I am left with, I'll write it in green, y is equal to negative 1 and x is equal to 4. Now let's go ahead and see if we're correct, right? This is going to be my answer, but who knows? Maybe I'm just making it up, right? Maybe I have done it incorrectly. Let's go ahead and plug it back in. Okay, let's go ahead and take a look at the second equation first. X over here, which is 4. 4 plus 2 times negative 1. Well, 2 times negative 1 is minus 2. 4 plus negative 2 is 2, so I can check that off. So that's very good. I know I'm correct. And of course, if that's correct, 9 out of 10 times, of course, my first equation is also correct. But let's just go ahead and try it. 4 times 4 over here is 16, plus 3 times negative 1 is going to be negative 3, and then of course 16 plus negative 3 will be 13. So I know I've just double-checked my answer, and this is my answer. Y is equal to negative 1 and x is equal to negative 4. This is how you do it by substitution. Now let's go ahead and look at it. What happens when you do it by elimination? Okay, so now this is the exact same equation we were just working with, and in green I'll actually go ahead and write down what we got as the answer for the last for when we just did the problem. Y is equal to negative 1 and x is equal to 4. Let's go ahead and see if we can go ahead and get this answer another way, and another way meaning by elimination. Okay, this is a second way you can go ahead and approach this problem. Whatever feels comfortable for you, of course you want to approach that problem. Now this is so the way you approach elimination is you want to go ahead and make sure that one of these equations, either the bottom one or top one, have a common, not a common number. What do I mean by that? A common term, but not only a common term, but I mean the exact same term with its coefficient, meaning that, let me first show it to you so it's more clear, okay? I have a 4x over here, right? If I can somehow make this equation into a 4x, it's going to be very useful for me because I can go ahead and subtract the first equation by the second equation, and I can go ahead and eliminate automatically one variable. What do I mean by that? Okay, once again, let's just go ahead and first do the problem first, and then you'll get a better idea. And of course, I'm going to show you several examples. So I want to go ahead and make the second equation, instead of x, I want to make it 4x. How do I do that? Well, I can go ahead and multiply this entire thing by 4, could I not? Right? So if I go ahead and multiply the entire second equation by 4, that's going to give me 4 times x, which is 4x, plus 4 times 2y is 8y, is equal to 4 times 2, which is 8. And on the top, I have 4x plus 3y is equal to 13. Now, very important, what you're doing is you're going to be subtracting the first equation from the second equation, and how you want to approach this is just solve it down vertically, okay? And now, what do we have? Okay, let's see. Well, 4x minus 4x is just nothing, right? It's 0x. It's 0x, so it's nothing. So this completely cancels out, okay? The next one is going to be 3y minus plus 8y. Well, when I have a minus and a plus, it's simply a minus still. So it's 3y minus 8y, which is going to be minus 5y, is equal to 13 minus 8, which is going to be 5. And now I can divide to solve for y, negative 5 to both sides. And y is equal to, well, 5 divided by negative 5 is going to be negative 1. You see, notice that we got the same exact answer, right? Now, what do? Well, now, since I know that y is equal to negative 1, I can simply go ahead and plug this y value right back into the either first equation or second equation. So since we plugged it into the second equation last time, let's go ahead and plug in this y is equal to negative 1 in the first equation. So our first equation is 4x plus 3y is equal to 13. If I plug in for y, which is negative 1, I will get 4x plus 3 times the negative 1, which is just negative 3. So it's 4x minus 3 is equal to 13, I can add 3 to both sides, and I have 4x is equal to 16. If I divide by 4 by both sides, I get x is equal to 4. And look, there you go, guys. You see, once again, I just approached, I got the same exact answer, but I approach it 2 different ways. The first way is called substitution. The second way is called elimination. Let's go ahead and try another problem just to make sure, because, you know, one example is certainly not enough. So let's go ahead and try another example. Let's go ahead and try this one. Let's say 5x plus 4y is equal to 1, and 3x minus 6y is equal to 2. Now you see, I wouldn't actually recommend you using the substitution method over here for several reasons. Well, number one, if I actually go ahead and isolate the variable, it will get very nasty. I'm going to have fractions, and then I have to go ahead and substitute that fraction in. I mean, if I can show you what I mean, but I would like you to go ahead and try it on your own scrap paper and see how nasty it can possibly get if you do substitution. Sometimes elimination is better. On the other hand, sometimes substitution is better. I mean, you just really have to kind of get a feel for it and kind of see if you can manipulate, which way is easier for you to manipulate the 2 equations over here, okay? And now if I go ahead and do my elimination method, as we discussed just a few minutes before, right, I know that I want to get one variable the same, right? Either it's going to be this variable over here, or it's going to be the 4y's, or the y variable over here. But if I just take a look at it, I see that I have 5x and 3x, and interesting. I can go ahead and actually, what's a common denominator between 5x and 3x? Well, isn't it 15x, right? Well, 5 times 3 is 15, right? Since I have a variable here, it's going to be 15x, which is a common denominator. Well, if I can somehow convert this into 15x and this into 15x, and I subtract both equations, it would make my life very easy, right? Just like we did before. Well, okay, so let's go ahead and manipulate both equations now. So in order to get the first equation to 15, I would have to ask myself, 5 times what gets me to 15? Well, 5 times 3 gets me to 15. So I have to multiply this entire equation by 3, and I have to multiply this entire equation by 5, because 5 times 3 will get me to 15. So let's go ahead and do that. So 5x times 3 is going to be 15x plus 4y times 3 is going to be 12y is equal to 3 times 1, which is 3. Please do not make the mistake, as a lot of people do. People always forget to multiply this number over here, okay? Please do not forget that, okay? The next one is going to be 5 times 3x, which is 15x, 5 times negative 6y, which is going to be 30y, is equal to 5 times 2, which is 10. And now remember, we are subtracting over here. And now 15x minus 15x cancels out. Now we have 12y minus 30y. So a minus and a minus gives you a positive. Please do not forget your basic rules of mathematics, right? Arithmetic. So a negative and a negative give you a positive. So it's 12 plus 30y. Well, 12 plus 30 is going to be 42y. Is equal to 3 minus 10, which is going to be negative 7. And now I can divide by 42 from both sides, and I'm left with y is equal to, well, negative 7 over 42. I can simplify that. If I divide both sides by 7, I should get negative 1 over 6. Yes, this is an ugly, ugly answer, but it is the answer. Y is equal to negative 1/6. And now, in order to solve for x, what I can do is now plug in this entire value over here, right? So I have y is equal to negative 1/6. Let's go ahead and see what we get then. So I have 3x minus 6 times negative 1/6 over here is equal to 2. And now let's go ahead and see what we get. 3x minus 6 times negative 1 over 6, which is simply going to give us a negative 6 over 6, which is going to give us negative 1. But please notice, so I have a minus sign here, a negative sign here. So it really becomes plus 1. So what do you get? You get 3x plus 1 is equal to 2. You can subtract 1 from each side. 3x is equal to 1. And I will get that x is equal to 1/3. Now let's go ahead and see if we're correct, okay? Who knows if we're correct? So I have, this is my answer, x is equal to 1/3. and y is equal to negative 1/6. Hopefully I'm correct. I'm pretty sure I'm correct, but let's go ahead and just double check anyways. Pick either equation. Let's just go ahead with the second equation. Why not? It looks a little bit easier. Let's go ahead and plug it in. So I have 3 times 1 over 3 minus 6 over 1 over 6, well, a negative 1 over 6 is equal to 2. Well, 3 times 1 is 3, 3 over 3 is just 1, minus, well, I know that this minus and this minus is going to give me a positive, so let me just say that this is a plus. 6 times 1 is 6 over 6 is going to be 1. 1 plus 1 is equal to 2, and yes, 1 plus 1 is indeed equal to 2, okay? So go ahead and now, if you want to, please go ahead and plug these two variables into this equation and make sure it is correct, okay? So I've used for this question the process of elimination. Not the process of elimination, but I've used the elimination method. If you want to, go ahead and try to do the substitution method to get some practice. Let's go ahead and take a look at one more question. Okay, so here is another problem. Right off the back, let's go ahead and do elimination again, just because I think it is definitely a good way to approach the problem to the exam if you do have a linear equation with two variables, which you probably will. So let's see. Think about it yourself, right? How do you manipulate this equations to go ahead and try to get at least one common number and variable within them? What would you do? Notice how I can go ahead and multiply this entire equation by 3. Why? Because 3 times 2 is 6x. If I can get this to 6x, well, look at my second equation. I already have a 6x here, so it works out beautifully. So let's go ahead and multiply the entire first equation by 3. So 3 times 2 is 6x. Let's use a black color. So 6x plus 3 times 4 is going to be 12y is equal to negative 10 times 3, which is negative 30, right? Please don't forget that. Subtracted by just the second equation. Don't do anything to it. Do not manipulate it. 6x plus 3y is equal to 6. So now what are we left with? 6x minus 6x, okay. 12y minus and a plus, so a minus and a plus gives you a minus, so it's 12y minus 3y, which is going to be 9y is equal to negative 30 minus 6, which is negative 36. And now if I divide by 9 to both sides, I should get y is equal to negative 4. Y is equal to negative 4. So let's go ahead and write that down here. Y is equal to negative 4, and now immediately, the way I find out for x is I want to go ahead and plug this y in somewhere over here or somewhere in the other equation so I can go ahead and see what x is equal to. So let's use a different color. Let's go ahead and plug it in. So I have 6x plus 3 times y, while y is just negative 4, is equal to 6. So 6x plus, well, not a plus because 3 times negative 4 is going to be negative 12. So 6x minus 12 is equal to 6. I can add 12 to both sides, and I get 18 is equal to 6x. And if I divide by 6, x should be 3. So x is equal to 3, and y is equal to negative 4. Let's see if we are correct or we're just crazy. Let's go ahead and see. I'll go ahead and pick the first equation to see if we're correct. So it should be 2 times x, which is 3, plus 4 times negative 4, and it should give us negative 10. 2 times 3 is 6, plus 4 times 4 is negative 16, and yes, negative 16 plus positive 6 is going to give us negative 10. So we are correct, okay? So this is the answer to this problem. So hopefully now you have a better understanding about how to approach linear equations with two variables. You have two options, substitution or elimination. Go ahead and try out a few more problems, and you should be very comfortable with this subsection of the topic.